Okay, so we just finished question B. So here's number C. So what maximum height does the ball reach? So again, if we remember our parabolic path, we're trying to find out how high does that ball go. So we're looking for some wide distance or wide displacement. So we can bring out this question. We have dy is equal to v0yt plus 1/2 at squared. So we are trying to find out dy. So we have dy is equal to, our initial velocity in the y direction was 29.6. We solved for that previously, 29.6 meters per second. Now I found the time the ball was in the air was 6.04 seconds. So the time to reach the vertex is going to be exactly half that value. So 6.04 divided by 2, we get 3.02. So time is 3.02 seconds plus 1/2. Be careful with our signs. We defined up as positive. So this one, because the ball is being hit upwards, is a positive value. But our acceleration is actually down. 9.81 meters per second squared. And notice how I put that negative sign in there. Again, our time is 3.02 seconds. And we are squaring that according to the equation. So you have 29.6 multiplied by 3.02 plus 0.5 times negative 9.8 times 3.02 squared. And we end up with a height of positive 44.6 meters. Question D, how far from the batter does the ball land? So remember, in this direction there is no acceleration, no acceleration in the x direction. So I start with this equation, dx is equal to v0xt plus 1/2 at squared. But because there's no acceleration in the x direction, this just goes away. That becomes 0 because a is 0. So we can see that dx is just equal to vxt. Our velocity in the x direction was 22.2 meters per second, and our time, that's the time in the air, is 6.04 seconds. 22.2 times 6.04, we get 134 meters. What is the velocity vector at the maximum height? So I actually don't need to solve for this one. Let's just think about this logically. We said that at the vertex, at this point, we only have horizontal velocity. And velocity in the horizontal direction does not change. So we actually know the velocity at the maximum height will just equal to Vx. So that is just equal to that 37 cosine 53.1. We got 22.2 meters per second. What is the acceleration vector at maximum height? Yeah, we know acceleration has not actually changed. So acceleration has not changed. We know that acceleration AY is still equal to negative 9.81 meters per second squared. What is the velocity vector when the ball hits the ground? Hits the ground. So as we mentioned before, because of symmetry of our parabola, let's fix that parabola. Okay, so because of symmetry of the parabola, we know the velocity vector, the magnitude of the velocity vector here is the same as the magnitude of the velocity vector here, because it lines up along some horizontal distance. So if this vector is 53.1 1 degrees, and I know this vector is 53.1 degrees as well. So instead of up, it is down. If the magnitude of that velocity vector was 37.0 meters per second, then the magnitude of this other vector is also 37.0 meters per second. So our velocity at this point is actually 37.0 meters per second, 53.1 degrees below the horizontal line. So before it was above the horizontal, now it's below. And our last question is, what is the position and velocity when t is equal to 2 seconds? I'm just going to draw that parabola again. Here's our parabola. We know it took 6.04 seconds to get to the end. This is half, 3.02 seconds. We know 2 seconds is probably somewhere around here. So we're trying to find out what is the velocity at that point and the position. So let's do that right here. So let's do the velocity first actually. So we know that Vx is still 22.2 meters per second. Let me actually go ahead and solve for dx. Dx is just going to be Vxt. So that's equal to 22.2 meters per second multiplied by 2.00 seconds. So you see dx is equal to 44.4 meters. Okay, so there's our Vx, and there's our dx. Now in the y direction, you see that we can say Vy is equal to V0y plus AT. You can say Vy, we know our initial velocity was 29.6 meters per second in the y direction, plus negative 9.81 meters per second squared, and our time was 2.00 seconds. So 29.6 minus 9.81 times 2, we get 9.98. So Vy. Get 9.98 meters per second in the y direction. Our position, on the other hand, we can use dy is equal to V0yt plus 1/2 at squared. Dy is equal to, again, our speed we know that's 29.6 meters per second. T is 2.00 seconds. Plus 1/2, our acceleration is negative 9.8 meters per second squared. And time is 2.00 seconds squared. Let's plug that in. 29.6 times 2 minus 0.5 times 9.8 times 2 squared. We get 39.6 meters. So you can see our position is 44.4 meters to the right, 39.6 meters upwards. And finally, we can solve for our velocity vector. So again, we need to find out what is the height. We found the x direction is 22.2. The y direction is 9.98. So now we need to use a squared plus b squared equals c squared. We get our velocity at that point. So 9.98 squared plus 22.2 squared, square root. We end up with a speed of 24.3 meters per second. And so here's my triangle, 22.2, 9.98. So we just solve for V. And we can see that our angle is going to be inverse tan of 9.98 divided by 22.2. Get 24.2 degrees above horizontal.